You look at a city skyline and you just see steel, glass, and concrete.
Yeah, that's what's on the surface.
Right. But what you're really looking at is a mountain of fulfilled promises. I mean, in our daily lives, a promise is usually just a few words. You tell a friend you'll pick them up at the airport, and they trust you.
It's just an invisible bond.
Exactly. But when it comes to mega projects like the international airports, the hydroelectric dams, massive suspension bridges, trust doesn't cut it. A promise has to be transformed into this mathematically rigorous, heavily scrutinized binder of guarantees.
It is basically institutional paranoia committed to paper.
Yeah.
And for good reason.
Oh, absolutely.
When you are dealing with billions of dollars and thousands of lives, you cannot rely on blind optimism. You need a system that forces an organization to prove their competence before a single shovel even hits the dirt.
Which brings us to today. Welcome to today's deep dive. Our mission today is to decode the anatomy of that exact system.
It's quite a document.
Yeah, we are looking at the contractor's proposal for the FIDI Conditions of Contract for Construction, specifically the first edition 2017.
Widely known as the Red Book.
The Red Book, exactly. And for anyone tuning in who isn't steeped in international construction law, FIDI stands for the International Federation of Consulting Engineers.
Right, and that organization was founded over a century ago to solve a very specific problem, which is standardization.
How so?
Well, imagine a French contractor, a Japanese financier, and an American architect all collaborating to build a railway in Kenya. The legal and logistical chaos of merging those different business cultures would stall the project indefinitely.
So they needed a baseline.
Exactly.
Yeah.
FID created a common language. The Red Book is essentially the global gold standard rulebook for projects where the employer does the design and the contractor executes the build.
Looking through the source material, I realized that submitting a proposal under these rules is not like bidding on a normal job at all.
Not even close.
It's less like a standard business contract and more like a mix between a high-stakes prenuptial agreement and like a sci-fi world-building Bible. You aren't just pitching a price tag. You have to legally and mathematically prove who you are, how you think, and how you will survive when everything inevitably goes wrong.
The entire document is engineered to strip away a contractor's ability to fake it.
Right.
You can't just throw out a lowball number to win the bid and figure out the logistics later. The proposal forces you to show your work up front.
Whether you're managing a corporate team, planning a massive event, or just curious about how skyscrapers and bridges actually get off the ground, you're going to learn how the pros plan for absolute worst-case scenarios.
And that gauntlet starts with proving you actually have the stamina to play the game.
Yeah, before a company can explain how they will build something, they must prove exactly who they are, right? And that they aren't spread too thin to succeed.
Precisely. The employer, the entity actually paying for the build, doesn't just want your company name and a list of past triumphs.
They want the receipts.
Oh, they demand your audited financial turnover for the last 3 years, alongside a deeply detailed breakdown of your current workload and capacity.
Why do they care about the current workload so much?
Because it targets the most common silent killer in construction. Companies rarely fail because they don't know how to pour concrete or weld steel.
Right, the engineering is usually sound.
Yeah, they fail because of cash flow crises and over-leverage. If a contractor is juggling 10 other massive active contracts, pulling crews and equipment from one site to put out fires on another,
The project suffers.
exactly. The employer needs a mathematical guarantee that sufficient resources actually exist to finish this new job.
They want absolute proof you aren't robbing Peter to pay Paul.
Yes, and that scrutiny extends directly to the human beings running the site too.
The key personnel schedule.
Yes. You have to submit the specific names and resumes of the people who will be on the ground. Project managers, HSE health, safety environment managers, lead surveyors.
But wait, okay, let's unpack this. If my lead engineer quits or gets promoted, I can't just sub in someone else from my bench. I literally have to ask the client's engineer for permission.
What's fascinating here is how this prevents the classic bait and switch.
Oh, meaning they pitch an all-star team just to win.
Exactly. The industry has a long history of a contractor wanting to win a lucrative bid, so they submit a proposal featuring their most brilliant, seasoned experts. The employer is impressed and signs the contract.
And then what happens?
On day one of actual construction, those 20-year veterans are magically busy on another continent, and the contractor quietly swaps in inexperienced junior staff to save on payroll.
Oh, wow. But practically speaking, you can't chain someone to a desk. If a brilliant lead engineer gets a massive promotion or a better job offer from a rival company and just quits, the contractor can't force him to stay.
No, the strict rule subclause 6.12 doesn't stop human turnover, but it fundamentally shifts the burden of proof.
Okay, how so?
If that lead engineer leaves, the contractor can't just quietly slide a junior employee into the role. They have to formally notify the employer's engineer, present a replacement candidate who has the exact same or better qualifications, and the engineer holds absolute veto power.
So if the replacement isn't up to the standard of the original promise, the whole project stops.
The project stops. It forces the contractor to absorb the cost of headhunting top-tier talent rather than passing the risk of incompetence onto the client.
That makes total sense. So once that dream team is locked in, the focus shifts to the physical execution.
The transition from the who to the how.
Right. And reading through Section 4 of the Construction Execution Plan, here's where it gets really interesting. They aren't just pitching a bridge. They are pitching the creation of a temporary pop-up town that exists solely to build that bridge.
It's the architectural blueprint for the logistics.
Yeah, like if you are building a billion-dollar power plant in a remote area, you require worker canteens, hazardous material storage, temporary power grids, water, and even fully operational on-site concrete batching plants.
You're building a mini-city that operates for 4 years and then vanishes.
Exactly. Why is this required in such detail up front?
Because failure in construction rarely happens at the final step. If the temporary power fails or the on-site prefabrication plant goes down, the entire timeline dies. Logistics is the project.
And to manage that cascading risk, the proposal demands a highly granular tracking system, usually run through industry software like Primavera P6.
Right, the critical path method.
Yeah, it's not just a spreadsheet. It calculates this critical path, the longest sequence of dependent tasks that must be completed on time.
Right, and they use float analysis. If you're painting the interior walls of a new airport terminal, that task might have 2 weeks of float, meaning you can delay the painting by 14 days without pushing back the grand opening.
But pouring the main foundation has zero float.
Zero. It is on the critical path. If pouring the foundation is delayed by a single afternoon, the opening day of the entire airport is pushed back by an afternoon.
And the level of detail feeding that schedule is staggering. In the resource plan, the contractor has to track the exact mobilization month and the condition like, the specific age and running hours of every bulldozer and crane.
Think about the mathematical risk of an old machine. If you place a leased crane with 15,000 running hours on a critical path task, the statistical probability of a breakdown is high.
And if that crane blows a hydraulic line,
It doesn't just stop the crane operator. It stalls 100 downstream workers waiting for that steel to be lifted. The employer wants to know if you're bringing reliable tools or cheap liabilities.
plus they have to calculate the ratio of skilled tradesmen to unskilled labor.
Exactly, because balancing the workforce is essential for efficiency.
So building this pop-up town introduces immense physical risks to the workers, obviously, and social disruption to the locals.
Which leads us to the Hazard Identification and Risk Assessment Matrix, the HIRA.
Right, the HIRA. The contractor has to list physical risks, score them mathematically, establish strict mitigations, and score them again. We're talking about highly lethal scenarios here. Confined space entry, high-altitude crane operations, hot works.
And those hot works like welding near flammable materials require a dedicated permit-to-work system. A supervisor has to physically inspect the area for fire hazards before a single spark is struck.
And they also have to plan for night works, right? Dealing with fatigue and visibility.
Yes, specific lighting plans, shift rotation limits. They have to prove they aren't just making this up by submitting schedules for toolbox talks and emergency response drills.
But I always thought construction bids were just about concrete, steel, and math.
Yeah.
But there's a whole section on human rights and community grievance mechanisms. Is this level of social management standard?
If we connect this to the bigger picture, mega projects have massive socioeconomic footprints. A local protest over dust or a community grievance can stall a billion-dollar project faster than a supply chain issue.
Wow, okay, so the proposal requires them to hire a community liaison officer.
Exactly. Keeping the community happy is a critical risk management tool. The noise, the dust, the heavy trucks, it completely disrupts the local ecosystem.
Think about a multi-billion-dollar rail line cutting through an agricultural district. If your dump trucks are kicking up thick clouds of dust that ruin a local farmer's harvest.
That farmer isn't going to politely write a letter.
No. They're going to park their tractor across the access road.
And a single local grievance can blockade a site and bleed millions of dollars a week in delays. The community liaison officer is the pressure valve between the chaotic site and the neighbors.
And the social requirements go even deeper. Contractors must explicitly outline strict policies against forced and child labor.
Yes, complying with the International Finance Corporation's Performance Standard 2, or IFCPS 2, for worker accommodation.
Which requires proof that the workforce will be provided with safe living conditions, clean water, and sanitary food.
Because a severe labor violation doesn't just cause terrible human suffering, it invites regulators to instantly shut down the site. The logic of the Red Book is that moral hazards are financial hazards.
Okay, so you've kept the workers safe and the community happy, but how do you mathematically guarantee the building won't collapse or go vastly over budget?
Enter the paranoia of the quality and risk plans.
Section 8's Inspection and Test Plan, or the ITP. This completely changed how I view construction. It breaks down every major activity and assigns an inspection letter.
Specifically, witness points and hold points.
Right. So a witness point is basically where the engineer wants to watch, but you can proceed if they're late. But a hold point is basically like a save point or a boss door in a video game. You literally cannot progress to the next level of the build until the engineer inspects the work and gives you the key.
That's a perfect analogy. Take a concrete pour. The ITP mandates a hold point for the reinforcement steel. You cannot pour a single drop of concrete until the engineer signs off on the precise spacing and tying of that rebar.
Because once the concrete is poured, the evidence of sloppy steelwork is buried forever.
Precisely. And if a contractor ignores that hold point and pours the concrete anyway,
oh man, what happens?
the engineer has the legal authority to force them to jackhammer out $1 million of fresh concrete at their own expense just to prove the steel underneath was correct.
This raises an important question, though. How do contractors maintain their schedule while waiting for these constant hold point sign-offs?
That's where the risk register comes in.
Section 14. They aren't allowed to be blindly optimistic. They have to list every conceivable threat to the project and calculate a risk rating.
Yes, by multiplying the likelihood of the event on a scale of 1 to 5 by the impact of the event, also 1 to 5.
Giving a maximum score of 25, which is critical.
Exactly. They are evaluating things like unforeseen ground conditions. What if the soil reports were wrong and the excavators hit a massive shelf of solid granite?
Or what if material prices escalate because of a geopolitical crisis?
Right. The foundational rule of FIDIC is that a risk should be owned by the party best equipped to manage it.
Oh, so every risk has an owner?
Yes. If the risk is extreme weather, the employer usually owns the schedule risk, granting an extension of time. But the contractor absorbs the daily overhead costs. By assigning an owner to the risk of hitting granite or facing steel shortages, the financial burdens are clearly defined before signing.
The risk register proves they aren't blindly optimistic. They must financially and temporally plan for these exact delays.
Exactly. They use that float we talked about in the Primavera schedule to absorb the shock.
Okay, so the project is built, the risks are mitigated, the quality is assured. Now comes the hardest part, leaving without a trace while remaining legally tethered to the work.
Section 15, demobilization and site reinstatement.
Yeah, you spent months building a massive pop-up city just to build the real thing. Now you have to tear the pop-up city down.
The phased removal of temporary structures and environmental ground remediation?
But earning the practical completion certificate doesn't mean the contractor's off the hook.
No, because of the defects notification period, or the DNP.
The contractor must guarantee an on-call repair team and retain key personnel even after the job is theoretically finished and handed over to the client.
Essentially, they have to leave a garrison behind. They sit in a trailer for a year after the ribbon cutting, waiting to see if the HVAC system rattles or if a roof seal fails during the first storm.
They are financially obligated to fix their own mistakes. It completely neutralizes the temptation to do sloppy, rushed finishing work.
Because if they cut a corner today, they just have to pay a crew to come back and replace it 6 months from now.
It's brilliant.
It is. Think about how this level of accountability applies to our own lives and careers.
Oh, that's interesting.
Yeah, if we had to submit a FATI-style defects notification period for our daily projects or software launches, guaranteeing an on-call repair team for our own mistakes months later, how would that fundamentally change the care and quality we put into our work from day one?
I mean, if you had to physically stick around to repair every typo or rushed assumption you made 12 months ago, suddenly your promises carry real weight.
Exactly. It forces you to do it right the first time.
So, The next time you drive past a mega project, you'll know that behind the cranes and concrete is a massive binder of promises. The prenup, the mini-city blueprints, the risk matrices, and the absolute commitment to doing it right.
See the link in the description for free PDF download. Also, watch our other construction scope videos. Thanks for watching, please subscribe, and see you next time.